Welcome back to Code. I am Shivam Du and we are diving into another exciting coding challenges. Now, I have been a bit under the literally due to a viral fever, which is why I am not able to bring your our coding challenges. But fear not, I am back and ready to tackle today's problem with full energy. Today challenge comes straight from LeetCode problem 1915 tilde number of wonderful substring. It is a fantastic problem that involves string and some clear bits manipulation. So let's get started. Jump right into it. Our problem statement: we are given a string consisting of lowercase English letter A to A. A wonderful string is defined as a string where at the most one letter appears order time of times without any substring. Our task is to find, count, and all one non-empty substring. Written here number of the wonderful non-empty substrings. So our problem statement is here. Our task is to find the count of all wonderful non-substring with a given. So for example here we have this BA wonderful substring. A wonderful substring are a, and ABA. These are the wonderful string here. Wonderful string. And totaling to we have four number totals here four and starting from here A, B. These are the similar string. So our character is to find the string to nine substring here. First A, second A, third fourth B, fifth AB, and sixth AB, and seventh eighth A B, ninth A B B. And these are the ninth wonderful substring. Ninth wonderful substring approach. To solve this problem efficiently, we'll use here with masking approach along a hash map to keep track the count, maintain a mask to part of even and occurrence of each letter in the current of a substring. Parting for even or odd occurrence each letter in current string. First one we are maintaining our bit mask represent the partition about even and odd occurrence and after that to each letter in the current substring. Second, as we iterate through the string, we will update a bit mask update into each character. Third one, at each position, we will count the number. At each position, we will count the number of wonderful substring and position count of substring with the same or different partition of a letter. Number 4, and after that we will update the count of a bit mask here. Update of each bit mask in a hash map to the computation to avoid computation. So our first point is we will create a bit mask. After that they will perform a partition about the all substring and it converts into a even occurrence and odd occurrence to each letter of a current string. After that, update the bit mask here according to each character. And number 3, at each position current number of wonderful substring and at the position of a count of a substring. And after that, update count of each bit mask avoid computation. Next one, pseudocode. So our pseudocode here is initialize result in count is equals to here 0 and 1. Second, initialize bit mask 0 here. And third is iterate for each character C in a string through each character in a first calculate bit mask calculate bit corresponding to character calculate the corresponding bit mask. Next, toggle in the bit mask count of a substring ending at current position and after that iterate all possible substring with one in the and after that update the count of a current bit mask update on the current mask into the hash map and after that final record. And so our here in first one we have initialize the result here. After that count is equals to 0 1 and second point initialize a bit mask is equals to 0. Third one iterate through each character in a substring and after that corresponding bit in the bit mask and after that increment the result of a count of substring ending the current position. After that iterate through all position possible string with one letter removed here for a odd occurrence and even occurrence, and after that update the count of a current bit mask into the hash map. And next we have here result the final output our code here. Let's take an example. Input word is equals to A, B, B. Our first character we have A at the beginning, so we have declined it. And our second character is here A, and our third character is B. Our fourth character is our also for a B here. Fifth character is next character is 4 here, and after that whole string here whole is equals to A, B, and B. So our finally we have underlined the whole string BB itself count. We have count total 9 wonderful substring. First one is A, the second one is A, and third one is A, and fourth one A, B, next character A, B. These are examples here. We have count the total 9 wonderful substring here. And next another example number 3. Our input word is equals to E. Our second character is E also. Now count. We have count two wonderful substring H and E. These are visualization explanations should we make it easier to follow, understand how we will identify count wonderful substring in these examples. Let's talk code in C++ and in Python. So here is a code for a Python, and this is a code for a Python of this problem statement from code. First one we have written here after count bit mask is equals to get our output here, and after that here return a result. This is a code for a Python. And next we have code in C++. We have instead a long result here is equals to 0. We have using a hash map here, so we have used a map, an order map, and count initialize map to store accounts for each bit mask. Int bit mask initialize a 0, count is equals to 0 1, and for character word end bit character minus each letter, and after that result is equals to count plus equals to count bit mask. Here count wonderful substring ending at a current position. After a check substring with one odd letter removed, and after that update count of bit mask count bit mask plus plus, and after that return is submitted. Then so let's talk about our time complexity. The time complexity of our code is a code solution is O, n is the number of length of an input string. This is because we the string once and perform constant time operation for each character. So for this approach and understanding, let's dive into a code and solving this integrating problem. Here we have finished also. So our conclusion of this part on this video. So in this video we will tackle the LeetCode problem 1915 number of wonderful. We have to identify wonderful substring with given a string where at most one letter appears and odd number of times. We approach this problem by utilizing bit manipulation and a hash map to efficiently count the wonderful substring. By iterating the bit mask of each character, we are able to a substring problem. So what we will here our key point we have to remember here. Identify wonderful substrings where at most one letter appears and an order number of times. Utilize bit mask manipulation and hash map to efficiently count by a substring. And we have another key point remember here. Visualize the problem solving approach by step and each example. I hope this video help you understand how to approach and solve this problem effectively. If you enjoyed this content, don't forget to like, share, and subscribe to CodeRebel for more coding challenges and programming tutorials. Thank you for watching, and I will see you in the next video.